Gracias a todos por estar ahí. Y vamos con el último panel.
Let's resume, and we're going to start the next panel. I'm going to introduce him in English, so I can introduce Göran Marby.
Hello, Göran Marby, CEO of ICANN. Thank you very much for being with us this morning. We have a fantastic panel about ICANN. And thank you, Göran, for being with us. You are in Los Angeles. It must be in the morning there. I hope you are all doing fine. I will be moderating this panel. We have a fantastic panel. Göran Marby is the CEO of ICANN, and then we have Rodrigo de la Parra. He's Vice President, Stakeholder Engagement and Managing Director for Latin America and the Caribbean. Then we have Nicolas Antoniello, Regional Technical Engagement Manager, and David Huberman, Senior Technical Engagement Specialist of ICANN. We have a variety of issues to talk to you. During 1 hour, we can take some minutes from the break that we have after your panel. So feel free to expand your presentation. And Göran, welcome to the South School of Internet Governance. We have 500 fellows from all over the world. This morning we had questions from Bangladesh. Can you believe it? So this virtual model of the school is expanding the boundaries of the face-to-face model that we had for 11 years. So welcome to our school.
Good to see you again, Olga.
See you too. Virtually. It's been a while. We haven't met.
No, and I don't know about you guys, but I have to admit that despite the fact that the internet is working so perfect and you can do things virtually, I miss the interactions and the coffees and maybe even a glass of wine sometimes, sitting down and talking. That's one of the things I miss. Anyway, my friends, it's a real pleasure to be here for this virtual edition of the South School of Internet Governance. I mean, we are facing, some people would say difficult times, or other ones would say interesting times. And as I said, I hope you're all, first of all, I hope you're all safe and you're doing okay. In one way, I have one of the pleasures of my job is I reach out and talk to people all over the world in different time zones with different backgrounds. And one thing that's interesting with this pandemic, if I want to look at something positive, is the fact that it's also united a lot of people. Because I just heard there are 500 people from all over the world on this webinar, and that's a fairly unique thing. You have the ability to do it, you can be there, and we can have joint discussions, which are important. So before we start, just to explain, as not everybody knows what ICANN actually is. ICANN is a non-for-profit organization based in California and LA. And yes, I am in LA. The background picture is from my home country, Sweden, because I want to promote that as well. And ICANN is really a sort of tree with two branches. One of them is what we're going to talk about here is about internet governance, the governance part of what we do. But the other part is also a technical arm, and I think that some of my team will talk about that as well, is that literally ICANN provides all the world with all the technical identifiers, which is a very technical remit. And we work a lot with security, stability, and we work with partners such as the RERs, the country code operators around the world, and everybody else who has a top level domain. But now we're going to talk a little bit more about the sort of governance. One of the underlying principles of internet governance has always been that we do this together. We call it consensus models, we call it multi-stakeholderism, but it's really about people coming together, figuring out something and making it happen by actually talking to it. If people think it's a good idea, then it's going to happen. And it's been a really successful thing. If you look at it, internet as an entity, as a thing, was brought up by volunteers, by people who had different ideas around the world, entering a stage and having it happen. And for a very short period of time, we talk about 20 years, this technology has reached all the world. And we still have a lot of things to do. But it's, basically, we have, 3-4 billion internet users around the world, all connected to one single system. And we've done that by working together through what we call internet governance. We set the rules, we make sure that they're fulfilled, we find out new ways of doing it. So and if you compare it to any other decision model around the world, I would say that this has been the most effective one because it actually works. Another thing that is might to think about is the work is not done. Coming into the school and coming into different settings, you meet old timers like me, and you think about these people has been doing this for 15 years. They already have the answers. No, we don't. There is still a lot of things that we have to take into account going forward. How to make internet more accessible for people. I mean, one of the things that's very dear to our heart is, for instance, what we called international domain names. The fact that people can approach the internet from where they want in their own language, their own script, using a keyboard that they are used to, instead of have to use the Latin script or the English version. People who don't read from left to right or don't know what a dot is. We're not there yet. We're not going to be there until we have more people online. The interesting thing, if I look from the outside, that many of the discussions when it comes to internet governance and debates has resulted in anything from political declarations, action plan, commitments, definitions, principles, and the creation of very unique platforms and institutions. And to make sure that this is not only a philosophical discussion, this has resulted in interactions with high degrees of complexity, but they have been dealt with. So often I get the question about what is internet governance and how do you define it? It's actually not that simple. It's sort of a lot of different disciplines that comes together under one name. Some of the things we talk about is very technical. I don't know if you heard that, for instance, you have different, a lot of people talk about 5G. And in 5G, you even have set proposals that would be counterproductive to a global interconnected internet. You've seen things like they called new IP. It's got nothing to do with IP, which is done by organizations who wants to do this in a specific way to go away from the principles we have. That's a technical internet governance, so to speak. But we also have the political ones. I mean, over the years, you've seen more and more legal proposals that has a direct effect on people's ability to either do something on the internet or don't do something on the internet. And that's sort of a more traditional internet governance when it comes to political interventions. Many of those, by the way, has been for good reasons. Many of them is because they wanted to solve a problem they thought existed. Maybe sometimes not even thinking about the consequences of those. So in order to grasp how to navigate the internet governance, it's critical to understand how the internet works. Understanding the operational aspects of the internet helps us to distinguish with layers, players, and the roles and responsibilities. We often forget that internet, let's take one example of how many people misunderstand the way of internet. Many of the legislations today are about platforms, fake news, and I'm not, it's nothing negative with platforms like Facebook, Google, Netflix, HBO, whatever you have, TikTok, whatever you have in the country itself is safe, but not the internet. When you walk into a social media platform, any other platform, you actually physically leave the internet and you walk into someone else's computer. But we call that the internet. But when we talk about the internet itself, we actually talk about this open platforms that make it possible for you to virtually travel the world. And that is one of the most important distinctions you can help me with to putting out there, the difference between platforms and the internet itself. So to understand the underlying technology, you don't have to be an expert. I'm not. I have very gifted people who helps me. But to understand how it works is an essential part of how you can help to protect the open interoperable internet. So you're going to learn much more from my colleagues on this panel because they actually know much more than I do, and I willingly accept that. But take the opportunity to ask them questions about how this works. Take them to the opportunity, because one of the things what I'm saying is that it's not done yet, is that we also need more people coming into the system to make sure and preserve what we have. My end point of this is during the pandemic, people have turned onto the internet. It's been the livelihood for many, many people like myself and my whole team who hasn't visited our office for 6 months. We all do this work on the internet. We do that together. It's actually proven that the system works. It's actually worked without it worked with no hiccups. The original design of the system, when it was done back in the 60s, actually do work. It's been secure, it's been accessible, it's in a way, the underlying functionality of all of this has proven that it can actually help the world through a pandemic. But it needs to be protected in the future as well. It needs to have people working on it and questioning people like me and other ones coming into this. Are we doing it the right way? Are we thinking about the same thing? And there is no real answer to all the questions. We have to work on them together. So thank you for joining this, and you should adopt the same way I do, and my team knows that. I ask any question about anything all the time, and I want to understand. So I ask questions about things that I probably should understand from the beginning, but I really want to understand. So take the opportunity to ask those very gifted people on this panel as many questions you have. There's no stupid questions, because the final thing with internet governance is we do many things that no one in world history has done before. No one had created this system before. No one created the internet itself. No one has seen a technology that is so much around the world. And so regardless of when you're entering into this, you will realize that you're going to be part of something that with looking at questions that no one had an answer to world history before. So welcome for this, and thank you for coming into this. And Olga, I'm grateful for you inviting me. I'm looking forward to hear if there are questions, and I'm going to listen in before I have to leave in a couple of minutes. But thank you again, Olga, and best of luck for this Internet School of Governance. Thank you.
Thanks to you, Göran. I know you have a busy agenda, and you're so kind to share your comments and your thoughts with us, with our audience. It's precisely about having more people coming into this environment, into this family that we share the same interest for having an open internet all over the world. And this is the 12th edition of the school, and believe me, along these 12 years that we have been organizing this training program, every year we have to add new concepts, new speakers, new focuses, because it's like the journey is the destination in internet governance. It never ends, but it's okay if you understand whatever your profession or your work is. It's a good thing to have a general scope of all the issues that are related. This is the idea of the school, and thank you very much for sharing your thoughts and your comments. I do agree with you. I miss the coffee, I miss the wine, I miss the interaction a lot, and I also miss when we had this meeting in person, the applause at the end of every presentation. I really miss that. I miss the interaction, but we are hopefully that will come in the near future. So thank you very much for your time. Okay, should I switch to Spanish with Rodrigo? Rodrigo, are you there?
Yes, Olga, if you don't mind, I can go to Spanish.
Rodrigo, bienvenido.
Yes. I can do it in Spanish. Thank you very much. Are you in Mexico, Rodrigo? Yes, for the last 6 months I'm here. Yeah, I've been here for the last 6 months in a lockdown in Buenos Aires. Greetings to you and to your family. Let's welcome you to the school. It's a pleasure having you here. It's always a pleasure having you and ICANN panel. With my technical training, I'm basically attached to the technical essence of the internet. And what fascinated me along these years, dating back to 2004, 03, when I wanted to understand the functioning of the internet, I always came to ICANN as the cornerstone of coordination. So that was the primary focus for my PhD, and that is why I became so much involved in the organization that became so unique, it seemed to me. It's something that for us is fundamental. This internet that works perfectly well and allow us to be interconnected during the pandemic. Let's welcome you. And later I'm going to continue with the rest of the colleagues of this panel. Thank you very much. Thank you very much, Olga and Adrian, for having invited me and for giving me the chance to talk about on ICANN. My greetings to the students that are participating and attending this 12th edition of Internet Governance. As Göran said, these initiatives are very important because they prepare and they develop skills for people that in the near future, are going to participate proactively in some of the groups of interest that make up the ecosystem of the internet. and hopefully within the ecosystem of the world as we know it as the ICANN, that is the identification of names and numbers of the internet. We would like to approach this from the technical point of view of what ICANN does. ICANN primarily is an organization that is technical in nature, complex, and is a flagship for internet governance. We always, this topic always emerges in some of the conversation, in the conversations as the multi-sectorial dialogue platform. My way of participating with the multiple stakeholders and the multiple sectors, we can enjoy a very stable, interoperable internet. And during the pandemic, with the difficult times that we have, that we all need to go back to our homes, it became a stable tool that allow us to be connected to the rest of the world and in our daily lives. So we have technical experts like David and Nicolas that are going to address this from the technical point of view. But I wanted to explain briefly what ICANN is. ICANN can be seen twofold. First, in terms of technical operation, ICANN has responsibility to make this identification to work. And every time you type a website or a domain name in your browser, you can get to the right destination. Whenever you send an email or type, I mean, it's very technical, and apart from managing and coordinating content that the root servers have. So this is very, very important. Another thing is that it works as a multi-sectorial forum platform where all the decisions that impact domain names, okay, the identifiers are approached as multi-stakeholder from the bottom up. So you can see some space of participation to enrich, increasingly more this multi-sectorial approach. We have some online training in I Can Learn for you to see and for you to delve into detail into this ecosystem. Without further ado, I would like to thank you for the chance that ICANN is here sharing this, and I'll turn the podium over to my colleagues. Thank you, Olga. Thank you very much, Rodrigo. And I would like to mention Rodrigo's role in Latin America. They miss sharing wine and coffee with you, Rodrigo. I totally agree with you. Probably some tequila in the future, especially, what Rodrigo was saying is very important. We have many participants in the room, more diverse than ever before. For the last 2 years, we have online remote participation. However, with this virtual event, we have students from all continents and from all countries. So virtuality or virtual events promoted online participation or online attendance. It's only online right now, but we offer participation in internet coordination, regulatory frameworks, or policy or technology policies. ICANN is the forum to participate. It may seem complex at first. However, there are many courses online, as Rodrigo explained, or you can contact people from their staff that can provide them with documentation. The ICANN website has a wealth of information. And you may become involved in something that is super interesting for the coordination and the management of the internet. I urge you to visit their website to check their online activities, or you can send an email to Rodrigo. Tell us. Nico, Nicolas, your turn. You're up. Nico is not only a friend of ours, but also he attended the school in 2012 in Colombia when we celebrated his birthday. with all the rest of the students. And Adrian was there. Oh, yeah, it was Adrian's birthday at the same time. Two celebrations. He blew the candles, and then we went to have some steak in Colombia. So I always remember with a token of appreciation, it's like he's a part of, um, and a major specialist in ICANN, an expert on the internet. It's a great pleasure to see you. Welcome you to the school. Thank you very much. Thank you very much for the invitation to share this experience. We cannot say good morning because we don't know the time zone of every single participant. But here in Montevideo is like 1:30. So good afternoon to the rest of you. I always remember that celebration, the double celebration of these two birthdays, and the good times that we had in Bogota in that School of Governance. Without further ado, let me share the screen. Can you see the screen there? Sometimes it takes more than a second. Hang on a second. It's taking some time. Now we can see your screen. Good. The idea is to give you an overview, less than 20 minutes, on the domain name system. We are going to address it from the technical point of view. The objective is for you, or for those of you that know the domain name system, is to give you an overview. For those of you that are not familiar with this, to have an idea of what domain name system is and why it's so needed and how it works in general terms. First of all, we gotta see what the domain name system is, or why do we have one. This dates back to device mechanism, the terminals, telephones or computers that are connected to that network of networks that is the internet. So how we identify these devices? These devices are identified by means of an IP address with a number, and that is called IP address. Okay. Whether it is the initial version or the old version of IPv4, that is the one that we use nowadays, is the best medium to identify the devices or the internet, or the new version of this protocol, or a new one, that it would be too technical, that is called IPv6. That IP address is what identifies uniquely all these devices over the internet. Likewise, the same cell phones identify the terminals over the telephony network, or a cell phone or a landline network. The human brain, for most of us, it's easier for us to remember chains or related words or names instead of remembering numbers, especially long numbers or sequence of numbers. Imagine that IP addresses in IPv4, in general terms, are classified by sets of digits separated by points or periods or dots. And IPv6 is a cluster of numbers that are hexadecimal separated by a colon or by 2 points. By exchanging information, if you use this, it's going to be difficult for users. That's why we have this idea, just like a phone book or our agenda or our phone book calendar in our cell phones, we have a way of identifying these devices and a mechanism to translate that domain name to that identifier in order to have an exchange of information between the terminal, the devices. And that's how we have the idea of having a domain name system that is called domain name system. Okay. Originally, it was saved in a file, local file, where we have in every single device we have a long list with the names and with the IP addresses. Those were the identifiers. So if you wanted to connect with a certain device, what you basically knew is the name. The device was going to retrieve that file that matched the IP address that intended to have that exchange of information. They establish eventually the connection with that IP address, and then the exchange of information was reduced. To keep a list in a single file has several difficulties. Scalability is one. Imagine when it's growing in number, it's very difficult to maintain all this information in the same file. You need to keep record of that identical file in all the devices that make up the network or the internet in this case. Initially, that file is being exchanged using email or other transfer protocol file like FTP or any protocol. But you may think of this difficulty that we may have to use that mechanism as translation or name association or relation. And there we have a more advanced idea of evolving with that mechanism. And that would be like a database that is widespread and easily to manage with a standardized protocol to exchange information, to save it, to retrieve it, etc. And there we have what we call as, or we refer to as domain name system by its, or DNS by its acronym in English. So what is this DNS, domain name system? As we said at the very beginning, the idea was to have a system that is a database with a tree structure. So it's a repository of information. Data repository, in line with its original architecture, was conceived as a tree. That tree structure is called namespace. What we call domain names are the names allocated to every single device over the internet. And the IP address is the identifier, the single identifier associated or related to that device. So we have that database that is going to have that translation. So I'm going to ask for a query. I'm going to ask what is the IP address associated to a domain name. And the domain name system shall retrieve that name so I can exchange that information with any other device over the internet. From that point of view, the domain name system, the DNS, is critical for operating the internet. It's not that if it's discontinued, the networks are going to be down as such. They're going to keep working, even though without the DNS, the same problem is the problem or the challenge that we're faced with. Imagine that if we have a mobile device and we don't have any longer that, we don't have the contact list. I mean, we can keep using the numbers, but how many names I'm going to remember? Yeah, if I look for it, I establish information because it's related with the translation of the numbers. But if you lose that, it's not going to be functional any longer for users. That is why the domain name system is classified as critical information for the functioning of the operation of the internet, tracing back to the structure and the format of this database. Well, it looks like a tree, inverted tree, where the roots are going to be higher on top, And the branches, where every single level contains a label. All these labels are in the first level. So in the DNS, we know as primary DNS. And then we have secondary DNS, then the third level domain names, etc. And the lowest level doesn't have a label, is represented by a dot, and that is called root, the roots of the tree or the roots of the domain name system. So how do we refer to a domain name? In order to have a domain name, the way of name it is locating the label and all the sequence of labels up to the root, separating them with a dot. For, for example, this level or this domain that is www is not www only, because if I say that, it's difficult to distinguish the three of them that I have in the third level. So if I would like to refer to this one that is in blue, it has to be www.example.com and dot. The last dot we never said. We said .com and that's it. But now in the path up to the root, I'm referring only to this domain name. If I would like to refer to the main name email, it has to be mail.example.com. The same goes for all the domains, so any domain name with the inverted tree, okay? And naming every single label. Let me discuss the way that we classified internally this structure. And let me bring by way of example these concepts, the concept of name and the concept of zone. To facilitate this, let me trace some parallelism between the domain name system and a store, a grocery store. So what am I going to save in this grocery store? The translation between the domain name and the IP address. All the translations are going to be saved in this repository, in this grocery store that we call domain name system. From the administration point of view, if I want to manage these large grocery stores, later we're going to talk about distribution. So if I want to manage this repository that can be accessible by any user over the internet, what I have to do is to define an orderly fashion to do so, to manage it, and to delegate part of the management to different entities or organizations or managers. Not only manage it myself, but we manage it we manage part of the storage, and we basically have a smoother management. So the divisions from the administrative point of view are called zones. What is a zone? What's a zone like? Well, being formal and define it formally, it would be like a shelf within our grocery store. In the structure of domain name system, a zone would be a set of domains managed by a certain entity or organization where we delegate the management of that sector that is called zone. Who delegates that? The parent domain name. So this zone, example.com, is delegated to an organization managing this subtree. Now, who delegated example.com? Well, it was delegated by the manager, that is the parent of example.com, delegating another organization the management of it. This is generally referred to as child zones, or parent zones, the one that executes the delegation. In summary, zone is a shelf within the grocery store, and the DNS, the zone is a set of domains managed by an entity that is defined as a label, and the whole tree is underneath. So domain.com is not only the label with level 1.com is the label plus the whole tree that is underneath in blue, okay? In general terms, this is information that is saved in every single box. This is a translation between IP and domain names, and we also save some other type of information like inverted resolution, the name associated with the IP address, but the opposite. I'm telling you the system. This is the IP address, and then it's got the translation into the domain name. But the most common use of what users use is I give you the name and I know or I want the IP address. Let's address the name resolution process in action. How it works with the device, establishing that exchange of information with a new device or the internet, and how it works. Okay, let's see some concepts here. We are going to see the resolver. It would be a recursive server. Resolver is a word that I don't like that much in Spanish because it doesn't make any sense. I prefer recursive server. That is the one that receives the queries, looks for information, and then returns the result, delivers the result. Okay, so we're going to receive the query, the domain name, look for the IP address related to this, and deliver to the user that IP address that is associated to the domain name that it is being queried about. Okay? To trace and parallel with the grocery store, the recursive server is going to be responsible for looking for the product and deliver it to the client or the customer. Name servers. Authoritative servers are the ones that hold the information or host the information and have the authority to manage that information that belongs to a domain name. So those are the boxes that save or that hold that information associated to every single domain name. Those, the shells, the equipment, the servers, will always save the equivalence between the IP address and the domain name. Authoritative servers are the ones that have this information. The records are the ones that query this information for clients, and then they deliver it. That process of seeking that information on behalf of recursive servers in the authoritative servers and therefore delivering their result to the customer is what we call resolution process. By way of introduction, let me give you two examples: the caching concept, memory, and replication. What is caching? Let me explain caching in this way. A recursive server, we say that tracing similarities to the grocery store is the one looking for a product in a shelf in the zones, okay? And they look for information. Imagine that I'm the person seeking that information. I'm asked the IP address. I look for the information. I got that address. I deliver it to the person. And basically, I fulfilled the task that I was asked. If I got queried about the same thing and about the same domain name, instead of looking for that IP address, if I already looked for it because I had the same query in the past. I could memorize it. And that is caching, not to retrieve the same information. And that is why recursive servers have a cache memory where they save their replies to clients based on their queries. So if another user or device starts asking the same query, they can provide that immediately and they save time by looking for it. That cache memory, then, that information that is saved cannot be saved forever because memory or the IP address could be changed. I mean, I could change that information if it's associated to a domain name. And if the recursive server is not looking for it, that name is not going to be effective, or that change is not going to be effective, and it's not going to be reflected. So they save that information for some time, and after some time, they erase that or they delete it. And if they do not have that information on the query, they look for it. But meanwhile, if it's in the cache memory, they save time by looking for it. Second concept, replication. Instead of keeping the information associated to a special domain in a single authoritative server, I save it in many servers. All those servers have the same information. Thus, instead of asking a single server, I may ask any of the replication because they all have the same information and they can reply the same thing with accuracy. So replication is keeping copies. We are maintaining several copies in our shelves in different domains in different places with a wide distribution. So the recursive server looking for that information may resort to finding this in the nearest server over the internet. In the jargon, we say the nearest is not the nearest in physical distance terms, but we refer to far or near in terms of network. So the the time that it takes me to go to the different points of infrastructure in the network should be faster. Okay. So recursive servers are going to use the repository information that I have at hand because they'll replicate this information. So it's going to take me less time if I keep it close. So that's why basically I query to closer. I retrieve it in closer servers. This rootservers.org site keeps an updated file of the number of copies and the way they are across the world. Authoritative servers in the root servers. Okay. Here we're speaking of the domains contained in the authoritative servers that have this information for the root zones. And here down below, I don't know if you can read, but it says less than a month ago, the number of copies of root servers accounts for 1,326 copies. So in a recursive server that would like to query a root server is going to be using the closest server in terms of geography or geolocation where they find this recursive server. Let me address right now the DNS components at a glance. By way of an example, let's see how this is produced. What is the process? When a client queries the domain name system for a name and expects to receive that associated IP address. Olga, is that okay? Yes? Okay, great. So how these queries work with the domain name resolution? Here we have a client that with a mobile device, we open the browser. Well, here we have Safari, an iPhone with Safari. And let's see that I would like to access the South School of Internet Governance. So that's I type the URL. And what the browsers can do to establish the connection with the web server and to display this website, what the browser has to do is to get to know the IP address where the website is saved in that server. But I type a name. I need the IP address so I can solve the DNS. The browser is going to start sending queries to an application. The query says, I would like to know the IP address associated to this domain name. Now, this local program, the operating system, in a way, is going to know the IP address of a recursive server. You know that recursive servers are the people looking for that information in the grocery store. Who could imagine, or who tells that IP address? There are many, many ways of configuring this or setting it up. You can do a manual setup, or my ISP, my internet service provider, when they delegate or they give me this public address, it's automatic and I don't need to set it up, and tells me what the recursive server is, where I make the squares to resolve these names. So in a way, my iPhone knows that IP address, and the same query that the browser receives send it to the recursive server. So my phone is making that queries. It says, I have this name, and I would like to have this address.
This example, I don't know the address. So let's suppose that we would like to know the IP address associated to the name www.example.com. So I'm going to request the server, the IP associated to that example.com domain. Let's imagine that the server has nothing in the cache, so it has to ask about it. Who is going to ask about it? Where in that tree structure is going to start searching? This is the chicken and egg situation, as we call it. We need to start searching somewhere. So some data must be in the server, and those data are the IP addresses of the root zone. 3 IP addresses, and all the servers have that set. So all the recursive servers know where they have to look for that. So the server is going to ask the root zone, which is the IP address associated to www.example.com. I always ask the same, the IP address associated to a certain name. The root server doesn't know the answer to that. Because remember that the root server is the first level or the top level. So what they are going to do is, since it doesn't know the IP address associated to that domain, it's going to try to give the closest answer. So in this case, the authoritative server is going to give the recursive server the best possible answer as regards that question. The server or the IP server for the domain. The recursive server is going to receive that and is going to ask the authoritative server the same question, the IP address associated to www.example.com. The authoritative server doesn't know the answer, but it knows the second level authoritative server. In this case, the IP address of the authoritative server for example.com. That authoritative server is going to give back the recursive server the IP address of the authoritative server of example.com. So what it's saying is, I don't have the answer, but you can go and ask the authoritative server of example.com. I know it because it is a level below my level. The recursive server is going to receive that and is going to ask to the other server the same question. In this case, if the authoritative server is also the authoritative server of www.example.com, so that server is going to have the exact answer to that question that is being asked. And it's going to give the recursive server the IP address associated to www.example.com. That recursive server is going to receive that information, is going to save it in the cache, and is going to send my phone the result of that answer, the answer. And that answer is finally going to reach the browser, is going to receive the IP address, is going to establish connection with the web page, in this case. And the page starts to download. And this is how it works. This all starts when my device is going to send the recursive server a question, and it ends when the recursive server gives me an answer. It could be the IP address, as it is in this case, or maybe another question when it is something that doesn't exist. The answer is going to be that doesn't exist. There is no IP address associated to that name. And that is the end of this mechanism. Finally, when this mechanism is finished, the answer is received, there is an exchange of information, and remember that the recursive server is going to save that answer. So if the same question is asked again, it already has the answer. And this is the end of my presentation as the domain name systems. It was a quick glance. And now I'm going to give the floor to Olga and David, that is going to give, I think, that a less technical presentation, and is probably going to answer some of the questions that you may have from this presentation, from the point of view of governance, how we manage the root zone and that.
Welcome. Can you hear me?
Yes, hi, good afternoon, Olga. Hello, everybody.
Welcome to the South School of Internet Governance. Just for you to remember, David Huberman is Senior Technical Engagement Specialist at ICANN. And welcome. Where are you, David? In which city? Where are you based now?
I am in Washington, D.C.
1 hour behind, so you must be hungry by now.
Okay, so we have talked today about internet governance. We've talked today about ICANN, and our friend Nicolas has given us a wonderful walkthrough about how the DNS works. So I want to bring that all together now. I want to talk about internet governance and the DNS, and specifically, I want to talk about this very, very important thing, the DNS root server system, a critical, a fundamental part of how the internet works and how it's governed. And I hope you find the next few minutes, it's a very short presentation, I hope you find the next few minutes interesting, because the governance model for the DNS root server system isn't exactly what we might expect. I first want to let you know this is not a technical presentation. It's interesting because when we at ICANN talk about the DNS root server system, most of the time we're explaining often to technical audiences how it works. We talk a lot about security and threats to the root server system, attackers trying to take it down. We talk about options for how we mitigate those threats. But what we always try and emphasize is how important it is. All of our devices, our phones, our tablets, our laptops, our computers, all of the servers and the software that are in big networks and enterprises and ISPs, everything works because the DNS root server system just works. It's resilient, it's stable, it's relatively secure, it's well architected, it's distributed around the world. And people are able to rely on it to just work. And because it just works, so too does everything we do on the internet. So how is it governed? And that's what I want to talk about today. And because it's such an important system, it's been the focus of a lot of internet governance discussions really over the last close to 4 decades now. To set up some perspective, I just want to talk really briefly about history. The DNS system that Nicolas very nicely described was actually born in 1983, 37 years ago. And the person who invented it, a gentleman named Paul Macapetras, set up a server. And its job was to be the root of the tree of the DNS. Those wire images that Nicolas was showing, that's a tree. And at the very root is a root server. And over the first 14 years of the DNS, we expanded that root server system. We started with 1, we went to 2, eventually we had 7 of them, and we noticed all of them were in the United States. So we started branching out, and by 1991, we had an international node out in Sweden. And in 14 years, we reached 13 root servers. And 13 is where we're at today. We have the same number of root servers 23 years later that we did back in 1997, which was a very different internet with a lot less users and a lot less traffic. For these 13 root servers, there are 12 operators. The very first one on the list, a corporation called VeriSign, is responsible for operating 2 of these 13 root servers. As you look through the list, you'll see some academic institutions, the University of Southern California and the University of Maryland. You'll see some government and military organizations, the United States Space Program, NASA, the United States Department of Defense, the United States Army. Sweden still runs a root server, an internet exchange company, a non-commercial company called NetNod. The RIPE NCC in Amsterdam, which hands out IP addresses and other internet numbers, has a root server. ICANN operates a root server. And finally, there's an organization in Japan called WIDE, and WIDE operates a root server. They were the most recent one to be assigned a root server. Now, we had this 14-year history where we grew the root server system from 1 to 13. But there was no governance structure surrounding this growth, surrounding this evolution. It was simply a small group of technical experts, really smart men and women, who discussed and debated changes primarily on a mailing list and sometimes in person together at industry conferences. Over time, there was no formal secretariat, but over time, an individual served the secretariat function. And that's the gentleman on the left here. His name is John Postel. This is him right here on the left. He's sitting in this picture with 2 other fathers of the internet. This is Steve Crocker in the middle. And on the right is Vint Cerf, widely credited as the father of the internet. But over here, John was the one who really administered much of the internet, the IP addresses and the domain names and the root server system. And ultimately, he really was the coordinator of how the root server system grew and who got its assignments. But unfortunately, after he assigned the final root server to Wide, he died. He died 10 days from now, October 16th, 1996. And interestingly, after John died, there was no system, there was no process, there was no formal governance in place to allow us to add, replace, or remove any of the 12 root server operators that we just looked at. Since John's death, our structure has had two main organizations. The first one is called ICANN's Root Server System Advisory Committee, which we call the RSAC, and the root operators meetings, and they refer to themselves as root ops. Now, root ops is not really governance. It's not how we would define governance here at the South School of Internet Governance. Root ops is mostly about technical coordination. It's the operators talking amongst each other about best practices and ways to operate a root server, a very complex system of servers and software. Root ops is a closed group. Only the root server operators are allowed to attend, and they only have very informal meetings. They typically piggyback off of meetings of the Internet Engineering Task Force. Now, RSAC is a little bit closer to what we think of as a governance body. Most persuasively, RSAC is organized under the bylaws of a formal governance organization, and that's ICANN. Per the bylaws, RSAC advises the ICANN community and the ICANN board on operation, administration, security, and the integrity of the root server system. But we have to be honest and say RSAC is only governance to a certain extent for two really big reasons. One, not everybody participates. Not all the root server operators show up at all the RSAC meetings, contribute to the work of the RSAC. And not everyone, and nobody has to abide by decisions the RSAC makes. No one in the world can tell an individual root server operator how to operate a root server. Nobody tells them what to do. The ICANN community and the ICANN board have no leverage over the root server operators. Compliance is voluntary. Participation is voluntary. And that's the extent to which we have had internet governance really over the 37-year history that we're discussing. So the stakeholders have thought about this and said this probably doesn't work moving forward. We need something better. We need something more formal. We need something less voluntary. They've thought about this for many years, and in June of 2018, the RSAC published a document. They called it a proposed governance model for the DNS root server system. And this was their model of what they think it should be. Who should govern the root server system, how they should govern, and how the root server system should evolve. Give it the mechanisms to allow it to evolve. And in this model, they want to solve 5 challenges about operating root servers. First was about the overall system, the strategy of how root servers should be architected and designed, and policies under which they should operate. They also want to make sure that we have a uniform system to measure and monitor performance of the system, the whole entire root server system, and individual root servers. Thirdly, it's expensive to run a root server. The 12 organizations I showed you, they don't get funding from anywhere. They voluntarily spend their own money to stand up and run their root server. So the financial considerations behind that, making sure everyone's on sound financial footing, is another one of the challenges that we want to solve. There's also the very basic issue. How do you add, replace, or remove a root server operator? And finally, look, you have all these different considerations and all these different functions. Let's make sure we have a formal secretariat, people who do this professionally, who can coordinate this new formal governance structure. The ICANN board looked at this and they accepted the RSAC's advice. And they've begun a community-driven process to develop a governance model. And this is where we are today. This is actually my final slide. Today we have a root server system governance working group. In shorthand, we call it the GWG. This GWG has been formed. It's comprised of stakeholders in the community, and they're actively working every week on publishing detailed and concrete recommendations for the 5 functions that we just described. Now, they've got quite a challenge on their hands. They have to do this in a way that respects the community's norms, our expectations for how internet governance is performed. Their recommendations have to be acceptable to a very diverse group of stakeholders: governments, domain stakeholders, end users, ISPs, and most importantly, their recommendations have to be acceptable to the 12 root server operators who, as we've discussed, are not today subject to any formal governance. And finally, the GWG also needs to look at how they're going to approach this, how they're going to form the secretariat, and they need to do so in a way that fits into what already exists at ICANN. There's an ecosystem around ICANN, and this needs to fit into that with minimal disruption. And that's where we're at today. Today, the GWG is working on the governance model. The ICANN community is watching. The ICANN community will be giving input. And eventually, a little bit of luck, we're going to have a new and formal governance model for the next 40 years so that the root server system is secure, it's stable, and it's resilient. I hope that was interesting to you. I hope you learned something from that. And thank you very much.
Thank you, David. That was very interesting. Honestly, I had in mind that information, but you brought it in a very detailed way. So thank you very much for that. I have only one question. We don't have much time because we at the half of the hour we have another panel and we have to do some arrangements. But I do have a question for the both of you. How are these servers that are installed all over the world financed? I mean, who installed them? Who buys them? Who pays for the maintenance of all these authoritative or root servers or DNS servers that you talked about, you and Nicolas? And an idea comes to my mind. We usually do webinars, which of course are open to the community and free for the same as the school, but more detailed, more focused. Maybe this is so interesting that we may organize a webinar in the near future with both of you. What do you think?
So, the financial considerations, it's a really interesting question, Olga. It happened very organically as more and more organizations join the internet. In the beginning, it was mostly military, government, and academic institutions. And in order for them to join the internet, they would have to set up an authoritative server, which they paid for. They bought it. They operate it. They pay for it out of their budget, their IT budget. Same with government. Over time, a lot of this has been overtaken by internet service providers. Internet service providers typically are commercial enterprises, and part of the cost of being a commercial ISP is paying for the DNS services that you need to provide to your users. For non-commercial ISPs, community networks, organizations that are setting up internet access out of goodwill for their community, again, it's a cost. It's a cost they can't avoid. Root server operators shoulder a tremendous burden, and they find different ways to distribute that burden, to spread out the financial costs among multiple organizations, and sometimes there's grant money available. But one of the most curious aspects of the root server system is it's paid for by the 12 operators, yet it benefits 4 billion users, most of whom don't even know they're doing that job. So yeah, it's a really interesting question, be a great subject of a webinar.
Okay.
What do you got?
So the invitation for organizing a more detailed and focused webinar We can have simultaneous translation as we did for this presentation. We can do that. Let's have that in mind, and maybe I can exchange an email with you. Unfortunately, I have to say goodbye to you because we have to do the arrangements for the next panel. If there are specific questions, I will forward them to you by email. Thank you very much. We are honored to have you. We are honored to have Göran in the program. Thank you very much for this. Very interesting. I will use part of your information for my classes at the university, so just for you to be informed about that. Okay. Stay safe. See you perhaps in the near future somewhere in the world. Bye. Hacemos una pausa, volvemos 1:30 con el panel de neutralidad de la red. Gracias.